In this video, you'll learn how to design an industrial bearing, brought to you by Science Mentor. Hi everyone, this is Milad. I'm back again with another AutoCAD 2026 tutorial for modelling an industrial part. The part we're working on is a bearing, and you can see its specifications in the image. Alright, let's get started. First, I use the unit command to set up the design units. I'm choosing millimeters. Next, using the circle command, I draw a circle centered at 0, 0 with a radius of 5 millimeters. This circle represents the inner diameter of the bearing. Then, I draw another circle with an 8.5 millimeters radius. For the outer ring of the bearing, I draw a third circle with an 11.5 millimeters radius, also centered at the origin. Again, using circle, I draw the outermost ring with a radius of 15 millimeters. Now, I need a guide path for the internal balls of the bearing. I use the elev command to set the drawing elevation to 4.5 millimeters. I draw a circle with a 10 millimeters radius. This sits between the inner and outer rings of the bearing. To make things easier, I create a new layer in the workspace. I name this layer Balls and change its color to red so it's easier to identify. Then I move the circle I just created to this new layer using the Properties panel. As you can see, the circle turns red. Now I draw another circle with a diameter of 4.763 millimeters. This is for placing the bearing balls. Using the 3D rotate command, I rotate this circle so it's perpendicular to the guide circle. Then I use the region command to convert it into a closed region. I switch the visual style to conceptual so it's easier to see. Next, I use the sweep command to sweep the small circle along the red guide path, creating a torus-shaped volume. This ring is the channel where the bearing balls will roll. Now I switch back to the main layer. The circles I created earlier now need to be extruded to a height of 9 millimeters, which is the width of the bearing. I start with the outer ring. I switch to 2D wireframe view. With both circles selected, I subtract the inner circle from the outer one using the subtract command. That gives me the outer ring. As you can see in conceptual mode, the outer ring is now created. Now I repeat the same process for the inner ring of the bearing. The subtract command in AutoCAD is used to remove one or more 3D solids from a main solid. It helps you carve out specific shapes from a larger object. I switch the view mode back to conceptual. Now I use the union command to combine the inner and outer rings into a single solid. The union command merges multiple 3D solids into one unified object. Once the rings are joined, it's time to subtract the balls layer from the solid body. This creates the path for the ball bearings. I go back to the balls layer and redraw the central guide circle, because I'll use it to position the balls along that path. I use elev again to set the correct drawing height. The elev command sets the elevation for 2D objects being drawn in 3D space. Now I draw one of the balls using the sphere command. The ball diameter is 4.763 millimeters. I use the red guide path to place it accurately. Using the array polar command, I duplicate this sphere 10 times around the center axis. The array polar command in AutoCAD copies one or more objects in a circular pattern using a center point and a set number of items. The bearing is almost complete, but I think it could use some rounded edges. I use the fillet edge command and set the fillet radius to 0.3 mm. This command lets you apply smooth, rounded edges to selected 3D solid edges. It is especially useful for industrial designs or models that need a more realistic or aerodynamic look. Now the bearing is complete. You can rotate around and view it from any angle. Follow me for more AutoCAD tutorials on this channel.